Good morning, girls. Today we are going to discuss about the next part of linked list. In the last class, we have seen the definition of a linked list, what is sequential organization and what is linked organization. What are the examples of those? What comes under what? Now, today we are going to discuss about linked list terminology and how it is realized using these arrays, all these things. Okay. So the first thing is, see here, header node. So what is a header node? A header node is a special node that is attached at the beginning of the linked list. This header node may contain special information that is nothing but metadata about the linked list. See, actually I will show you the diagram. See, this is the linked list, okay, which is containing actually four nodes. The first node is called the header node. Why it is called header node? See, it is a special node that is attached at the beginning of the linked list. It is called, should be always at the beginning of the linked list. And why it is called special? Because it may contain some special information about the linked list. What is the special information? See, it could be the total number of nodes in the list, date of creation, type of data that you're storing, etc. So it is not just storing data, it is also storing some extra information, excess of information or data about, actually what the definition of metadata is, data about data. So it is storing all about what the linked list is going to contain. On which date is created, what type of it is going to store, total number of nodes in that list. So that is the reason header node is called a special node, which is always at the beginning of the linked list, which specifies, which gives more details about the linked list. Next, data node. The list contains data nodes that store the data members and links to the predecessor or successor. See here, this node is called what? Data node. Why? Because it's storing only data, and here it will store the link to the next node. See, here it is this part is left empty. I mean, it is not empty. Actually, some data is stored here. Actually, this data points out, or this element here points out to the to this node where it resides in the memory. And here again, this will contain some information which will point to the next node, and this will contain some information which will point to the next node. So this is the link part of the data node. See here. See here. The list contains data nodes. So the linked list contains what? Data nodes that store the data members and links and to its predecessor or successor. Why we are using the term predecessor or successor? Predecessor means the link of the previous element. Successor means the link of the next element. See, actually here we're storing the link of the next element. But in double linked list and the other type of lists, you may need to store the link to the previous element also. So that is the reason we are seeing the data node contains actual data. Along with it, it also contains the link which points out to the next node. Next, head pointer. See, what is head pointer? A linked list must always have at least one pointer pointing to the first node or head of the list. This pointer is necessary because it is the only way to access the further links in the list. The pointer is often called as head pointer. See, this is the head pointer. Apart from header node, you are actually having a pointer called head pointer, which indicates the starting of the list. See, if you want to go to a particular place, first you should know the landmark, right? After going to the landmark, you can find out what the actual position is, where it is allocated, actually what it is having, which is similar to the header node. But going to the a place in the what needs you a landmark. In the same way, here head pointer is nothing but a landmark which will point out where actually the linked list is located, or from where it is going to start. So that is why it is called head pointer. Next, tail pointer. In the same manner, we have a tail pointer. Similar to the head pointer that points to the first node of a linked list, to have a pointer pointing to the last node of a linked list is called the tail pointer. So this is your tail pointer. So that indicates that this is the end or the tail of your linked list. So I hope it's clear. See, in linked list, we mainly have four things. One is header node, which is a special node, contains special information. Why we are calling it a special information? Uh, it contains data such as the number of nodes in the list, date of creation, type of data you are going to store, etc., etc. So actually, it is giving definition, or it is defining what the node is going to store. So that is the reason it is called header node. Next, data node. It is the actual data. It is the node where your actual data is stored, but that data node contains or stores the data members as well as links. Because to move on to the next node, you should always know where that node is stored. Because in this in linked list, these nodes are not stored in consecutive. I mean, near by one locations, consecutive locations. They are stored wherever the memory is free. Next, head pointer. This is the starting point of your linked list. I said you it is like a landmark to reach that place. So it will show where the actual linked list starts. Or the first node, header node of the list is stored this is shown by this head pointer, and in the similar manner tail pointer, which indicates that it is the last node of the linked list, or it is the end of your linked list, and this is what your linked list looks like. See, what are the operations that you can perform on this linked list? See, the basic operations, basic things that you can do on linked list are creating an empty list without any data, creating a list. Next, inserting a node. Next, deleting a node and traversing the list. So first one is creating an empty list. You will just define and leave it. Next, you will insert a node into the node in the sense this is called as node. It is what this node is, data node. So if you want to insert extra elements or extra node after defining, if you want to insert nodes, you can insert a node. That is one operation. Next, if you want to delete a node, if you do think it is not relevant here, I want to delete it, then I can delete that node. And traversing the list. What is traversing? Traversing is moving on from one node to the other node. See, if you have some 15 elements, you go on checking what is there in each and every node. So you will be moving from one, you will be moving from my first node to the second, second to the third, third to the fourth, fourth to the fifth. In that way, you will move till the end. So this movement is called traversing the node. You can read the data, or you can store the data. You can do whatever kind of operations you want to do through the by the traverse. Movement from top to bottom, or front to last, or first to last. Next, so based on these basic operations, you will do next operations. That is, these are called extra operations. So what are they? Searching a node. If you want to search for a particular node, if you are storing the details of students in this linked list type of data structure. Now you want to know the details of a particular student, or you that particular student is leaving the college, or has achieved something. So you want to know the details of that particular student. So you have to search for that particular node. So this is what you can do, searching of that node. Next, updating a node. You want to update the information or data which is present in the node. You want to change it. Then you can update the node. Next, printing the node or list. You can print only one node or all the nodes which are present in the list. Next, counting the length of the list. Length in the sense how many nodes are present at this point of time, because linked lists are dynamically allocated. So the starting value is completely different to the time when you do this counting operation. So counting the length of the list. Next, reversing the list. You just want to reverse the whole list. I mean, you want to turn, or you want to store the data which is in the tail or the last node into the first node, and you want to shift everything, you want to reverse it everything, you can do that also. And next, sorting the list using pointer manipulation. So if you want to sort, see the values in the, I didn't say that the values stored in the linked list are always sorted. I mean data in numerical values. They may not be in a sorted manner, like 4, 10, 5, 7, 0, 1. See, just see 10, 4, 6, 0, 1. So this is not a sorted list. So as these data items are stored in the linked list, now we want to put the items in the this linked list in a sorted manner. So you have to change the notes. You have to shuffle the notes. When you shuffle the notes, again the links will be the links have to be changed. So that is what sorting the list using pointer. Pointer is nothing but your link. By you manipulating those links, you will try to sort the list. Next, concatenating two lists. So if you want to combine together, say these two, this is one list, and this is another list. Now you want to combine these two lists, then you can do that, merging two lists, two sorted lists into a third list. See this concatenating and merging, what is the difference? Concatenating means you will just attach it. You are not going to change the positions of the data elements. They are just stored as it is. I mean, it is not in a sorted manner. You just this is you treat this as one list and this as one list. You will just what say attach or combine together the two lists, which will form a single list. Merging two sorted lists into a third sorted list. See, first you have to sort this list, second you have to sort this list, and you have to merge these and combine these together into one list again, which is sorted. Again, that third list should be also sorted out. So it is a very big operation. It involves so many steps. So I hope you understand how you merge to sort. This is first list, this is second list. You sort this list, you sort this list, merge these two lists, and again you have to sort, because after merging they are not in a sorted manner. So again you have to sort the third list also. So these are the operations you can do on a linked list. So the basic operations are creating, inserting, deleting, traversing, and based on those operations, searching, updating, printing, counting, reversing, sorting, merging, concatenating. Next, realization of linked list. So what is realization of linked list? See, actually realization is nothing but implementation. How do you represent this linked list in the actual memory? So how you are going to implement this linked list, which we are discussing here in practical. See, we will just see what actually definitions of what a node contains. See, a node is a collection of data and links. We all know that. Data is a collection of one or more items. So that the data field which is there is called, sorry, the data field which is there may contain one or more items also. Always, if there is no rule that it should contain only one item, it can contain one or more items. And one more thing, each item in a node is called a field. So here, see here, each item in a node is called a field. So this is one field and this is one. This is one field, this is another field. So this on the whole together is called node. This is called a node. All these are nodes, and each item is called in a node is called a field. So this is called one each item. There are two items here. One is data and one is link. So each item is called a field. Next, a field contains either a data item or a link. We know that. See, this field contains data and this field contains link. So it can contain either data or link. Next, every node must contain at least one link field. So, uh, every node should have this link field in compulsory. Why? Because through this link only you can move on to this next node. Through this link only you can move on to the next node. Through this link here only you can come to this node. So the link node is compulsory, at least one. Why we are specifying this for at least one? Because it's a single linked list, you are having only one link. If you use double linked list, you have to use two links. Circular list, you have to use two links. That is the reason we are saying at least one link is compulsory. Next, see, we are taking the months and the year and we want to represent this months in the form of a linked list, that through arrays. Yes, your linked list can be represented or implemented or realized through in two ways. One is arrays and the other one is dynamic memory management. Okay, so first we will discuss how to implement linked list using arrays. Madam, actually arrays have some disadvantages for which we have moved to linked lists. Yes, so how will you represent linked list using arrays? See, actual storage in the memory can be represented using arrays. So to understand the concept of linked list, we are first trying to represent it through arrays so that you can understand how the data items are actually stored. Let's see. So this is how your linked list is implemented using arrays. So here I have two arrays, the first one and the second one. Okay. See, the first array contains all the months, names of the months, and this is not an array, this is actually the index. Each array element has to be represented by its index, right? Indices or index. So this is the index list, and here this is the linked list. Actually this, so this is the linked uh, links that you are using in this list. See how actually the data is stored. Actually the data is not stored in sequential order. See, the first element of the array is not January, it is June. So they are not stored in a sequential order, and they are not stored in continuous locations. See, I have a gap here, I have a gap here. Okay, so they are not stored in continuous locations. So some memory is wasted here, right? Next, so this is your starting point of the array. Actually here you have head or head pointer which indicates the head pointer which indicates the starting of your list. So how the elements are read here? See, first through the head pointer we come to the starting of the list array. Here it is an array where we are storing the items of the linked list. So here we are coming to this place. Here what's the index? Index here 10. It is not 1, it is 10. The items are stored in a shuffled or jumbled manner. So from Jan, you want to move on to February. So how will you move? You have to check the link. So next data, sequential data is stored at node number 3. So I'm moving to index 3. See here. So February is stored at index 3. So now you want to go to March, and here the link is showing to go to place or index number 8. So here you see this is March and it is at index number 8. And here again from March you want to move on to April. It's showing 9. So again 9. So here is April. And May, see here 11. Shall we move to 11? See here May. So in this manner, you have to check the data. You can see the data and then go to the link. From there, you go to that particular link place. Link is nothing but here the links are showing the indices. We are representing it in the form of array. So here the links are nothing but the index places, indices. So in that manner, you will transfer. You will read all the 12 months, and finally you reach December. And here December, when you see the link, it is -1. So what does this -1 represent? It represents that it is the end of the list. So this is how your arrays are represented using one-dimensional arrays. See how the data is read here. So the head is nothing but starting at 10. I have written here. See, head is at index number 10. Index number 10. So head is equal to head 10. The data stored at that head is January. So from January, how you will go to February? So first, see, link of head, you will read link of 10. So this link of data of link of head is nothing but data at link of 10 is equal to data of 3, which is nothing but 10. See, link of head. So this is the header pointer. So what is the link here? 3. So what is it? Head. What is the index position? It is 10. So that is the written. I have written as link of 10. So you substitute data. If you want to read the data at link of head, so what you will do, you have to represent it as data at link 10. So what is there at link 10? 3. See, data of at 3. So now you move on to the position 3. Now you move on to the position 3 where you will find the actual data, which is February. And again, data of link of 8. So link of 8 is what? So link move to link 8. Okay. So data of link of 3. So data at 8. So it is March. So data of link of 10. Data of link of 1 minute. See, data of link of 10, that is January. Now data of link of 3, February. Data of link of 8, because the next position from February you have to go to March. So the data of link of 8. So what you will find? Here you will find March. Next, data of link of 9. You will go to April. So this is how you are going to search the locations and the data at those places. See, the link value, the last element is set to -1 to represent the end of the list. Okay, it can be set null or -1. So this is one dimensional array, and this is also another form of representing the array. Here the empty elements are left. I mean, they are not represented. See, here we are seeing empty places also, because in arrays we can't leave this empty places. They are to be shown. Here you can represent without showing those empty ones also. Actually, there won't exist empty ones. You will store only when there is data, when there is place. See, this is a node, say first node, second node, third node, fourth node, and this is your header. So here if you go data of link of 10, you will go to Jan, and data of link of 3, uh, you will go to 8. Okay, and data of link of 9, you will go to December. So this is how you will traverse the list, and you can represent the linked list using a 2D array as well, and this is how it is uh, declared in the program. Integer linked underscore list is the name of the list, your maximum number of elements, sorry, items, number of items or fields in this, and 2 means this columns, number of columns here will be 2, 1 2. Don't represent this as, don't take this index also as one more column. You will have 2 columns side by side, 2D array. Here you can put maximum number of elements depending on your requirement. So, but this is fixed, it is only 2D array, so that is reason I am fixing it as 2. Here the number of data, I mean rows, this represents column, so this represents rows. So the number of rows here can be maximum, max in the sense which can be assigned by you at the time of execution. So this is all about your linked list terminology, primitive, what the operations that you can perform, and how you represent linked lists using arrays, how you read the data, how you go from one link to the other link to read the data that is present in that node, and finally the end of the list. If you have any doubts, please ping me. Have a nice day. Take care.